So I figured we would. We got a decent amount of people. I figured we would start off kind of like we did in person, where we introduce ourselves quickly, and then how about we ask, or not ask, we share the first trip we're going to take once all of this is over, and what you're currently binging. So I'll go first. I think the first trip I want to take is probably Disneyland or Disney World because my kids have been driving me crazy together. And then I was binging on God, what's that show called? Somebody probably, that's where they go to Missouri and
Ozark.
Ozark, yes.
Yeah.
I had to take a break from that though, but it was good show.
It gets pretty crazy.
Yeah, I think Justin just inspired me that we should play a game of Name That TV series. He nailed that one in 4 words.
He did.
It's pretty good.
There's not a whole lot of shows that start with Missouri, so.
True. Yes.
All right. How about I volunteer the next person? How about Kevin goes?
All right. The trip that I want to take, I don't even know that. So I've been wanting to do a bikepacking trip through from Portland to the coast. That's been on my list. So I feel like if I don't talk to anybody, I can just do it.
Yeah, you can just do that, dude. Don't worry about it.
I can just do that.
Yeah, as long as you stay away from people, you should be fine.
I'll bring my mask. It'll be
Totally
great.
safe. Totally safe.
I've been binging. I have an excess of s'mores materials. So I've been staying away from the chocolate, so just a lot of graham crackers and marshmallows. Yeah.
I think we're talking about shows, not food, but I dig that.
Hey,
too.
I didn't see him specify. I didn't hear him.
Yeah.
Okay, good point. Good point.
Yeah.
That is a good point. But yeah, I was talking about TV shows.
TV shows. I'm trying to get my
No.
girlfriend to watch Last Airbender, and she's really not having it. So we've been watching Great British Baking Show, and I've started watching Office for the first time, which I haven't watched. It's okay.
Yeah,
It's
it's
good
okay.
junk food TV.
Are you talking about Last Airbender, the movie?
Nah, the show.
Series. There's
I was
a
going to
series.
say, yeah, watch the show first before you watch the movie.
Yeah. Let's see. Scott, you want to go next?
Yeah, okay. My name's Scott, and probably the vacation I want to do, I'd like to head back over to Pigeon Forge, Tennessee, which is kind of a nice little more relaxed, a little less crazier place than Disneyland. And what I've been binging on is salmon, believe it or not.
Good show.
Yeah.
Good show. Never heard of it. Is that on Netflix or?
Nah, he's just talking normal salmon, man. I think anyway. Yeah.
No, salmon the food, like pink
Okay.
salmon.
Yeah.
Sorry.
Do you fish for it too?
I'd like to, but right now I haven't done it yet. I haven't done it this year.
I hear there's a lot of good fishing
So
right now.
eat it
Delays.
raw, or do you cook it?
Smoke it? How do you eat it? Grilled?
Oh, I just
Broiled?
grill it.
Yeah, grilled's good. Cool.
Grill it with no grease on a non-stick pan.
There you go. And you get to nominate the next person to do an intro.
I'm going to nominate Trevor's cat.
Trevor's cat. I like it.
Trevor's cat, if I can get him to meow. We were going to go to the Republic of Chaz, but apparently the country is folded. So instead, I'll have to take a motorcycle trip to Montana. And I haven't really been binging anything. It's been a normal thing for me because growing food for all you people is an essential thing. So this has not really affected my work at all.
What's your cat's name?
This is Thomas for Tomcat.
Oh, wow.
So
Terrible.
how common we've got to specify when talking about Thomas the cat versus Thomas the Suco.
Mm-hmm.
Tomcat, the web server?
Or what about Thomas the Tank Engine?
Yeah, don't forget about
No,
Duncan.
no relation on this one. His name, he was named this by my daughter for being a tomcat because he was an outdoor cat and he's got a broken tail. So that's
That
his
makes more
little
sense.
thing. But he is a very friendly little guy here.
Now you got to get him to meow.
He eventually will when he wants food. But well, near the top of the my list here is Jesse. So go ahead, Jesse.
All right, so my name is
Wait,
Jesse.
he didn't talk about what he's been binging on.
I haven't been binging on anything because it's been normal work for me. I mean, I thought I effectively was laid off, but other people were perfectly happy to send me out doing the same crap I do and give me money to do it. So I don't know that I can say I've been binging on anything. I've been binging less. I mean, with my usual sushi place closed, it's a little hard to go binge on sushi. So
Doesn't that sushi place do takeout and delivery?
oh, they do, but it's
not
a
the
little
same.
harder to binge. It's not the same when you can just pull things off the conveyor belt.
Yeah.
So no, I've been non-binging. Maybe I'm binging on spending stuff. My cash outflow over the past couple of days has been huge.
Yeah, you're binging on an FT 891. That's what you're binging on.
Oh yeah, well that too. Yeah, that so $1,000 worth of radio, another $1,000 into the motorcycle recently.
That sounds like a
yeah.
binge.
Yeah, so I'm binging on spending. How's that?
So how much money did you spend on them solar panels?
I don't know because of the way that it went. It was a trade deal, so still gotta put those up.
All right, I derailed it. Sorry, Jesse.
That's all right. So,
Well, you're allowed to, Michael.
yeah, you're the moderator. So,
Not according to Jitsi.
No, you gotta get here earlier.
Justin's the admin. You're the moderator.
Exactly.
So my name is Jesse. Let's see where I'm gonna go. Friend of mine's in Michigan, so we've been kind of talking about me going over and visiting him. So probably once this all calms down, I might take a trip over to Michigan because I'm pretty sure I'm still going to be working remote, even though things start to open. Just since everything's already working pretty nicely with conference calls and all that, so they may just keep our group working from home. And then for binging, I don't usually binge on like Netflix as much anymore, but what I do is on YouTube. So I just watch various things, Dark Horse podcast, different podcasts, Dark Horse by Eric Weinstein, The Portal by his brother. Oh no, Eric and Brett Weinstein, if you guys have heard of them on YouTube, Joe Rogan. So mostly just podcasts and documentaries on YouTube that I watch.
Cool.
Very stoic of you.
Yeah. So Justin, how about you?
Sure. Hey guys, my name's Justin. Local guy who works at Fuse and Confluent. I have been binging on what's it called, Tales from the Loop on Amazon, which is a pretty interesting sci-fi series, although it's kind of dark, and I've been watching it with my wife and my 10-year-old daughter. I really want to get into the Last Airbender series because now that that's up on Netflix or wherever it's at, I've seen bits and pieces of it over the years, but never the entire thing. And my daughter's kind of into anime stuff, so I'm thinking it'll be a good candidate.
You won't be disappointed. It's a good show.
Cool. All right. Well, I nominate our presenter Rick next.
Okay, thanks. Let's see. What was the first question? Vacation?
Oh, vacation, yeah, and I didn't really say where I was going to go. I don't really have any plans to go anywhere, but maybe camping on the coast, which I may be able to do soon. Anyway, I'll have to hit Kevin up if I do that because I like doing that trip.
Yeah. So let's see. So this next week, this weekend, I'm going to spend some time in the mountains outside of Dayton for a couple days, and
Like
then
Ohio? Dayton, Ohio?
no,
Oh, okay. Dayton,
Washington.
Washington. Oh, I didn't know there was a Dayton, Washington. Cool.
Well, now you know.
Now I know.
Yeah, it's about an hour and a half east of here, southeast of here. It's past Waitsburg, past Walla Walla, or not quite the direction of Walla Walla, more northeast Walla Walla. Anyways, and then I'm gonna basically right after that, gonna bust it towards the coast and try to work from the beach for a couple weeks. Yeah, so pretty excited about that. Let's see. Shows, yeah. As far as binging goes, I've been watching. I think I've been averaging about one episode of Community per week on Netflix. Maybe 2 episodes if I'm lucky. So not quite binging, but I freaking love Community. It's hilarious. It's just one of the wittiest. I'd say probably the wittiest sitcom I've seen since Arrested Development, if you could call Arrested Development a sitcom. Anyways, I guess that's it for me. Let's see. There's some anonymous people here.
Yeah, I was going to say, fellow Jetsters, if you want to click the 3 dots in the lower right-hand corner, you can put your name in, or we're not going to totally out you guys. If you want to remain anonymous, you can.
So I see at least one person is not from the Tri-Cities, so I nominate him.
How do you see that?
Because I know him.
Well, Kevin.
Yeah. So, Devin Wilson, want to jump on and say hi? Or sorry, Devin Owen.
Yeah, true. Hey guys, I'm Devin. I'm actually down in San Diego, but I work with Rick. So he invited me here, which I'm really excited about. Let's see. I think the first trip that I'm going to take is to Yosemite later on this summer. Try to get there and just like chill out, not near the crowds. And I have been binging. Have you guys seen What We Do in the Shadows? Either the original movie or the TV show?
I've been eyeing it, but I haven't watched it yet. You recommend it?
Yeah. I mean, have you seen the original movie?
No.
Okay, well, watch the movie first because it's gold, and then like the show's totally new cast and plot and everything, but they carry through a lot of the sort of same feeling of the humor. So totally worth it. Yeah.
Cool. Will do.
That looks awesome.
Yeah. No, it's great. All right. Who else is coming out of the shadows like I just did?
You got Paul. You got Chad.
Paul, Bryce, and Chad.
Ooh, Paul. That sounds great.
So I found out I could put my name in by going to the chat, and then it would ask me for my name.
Nice.
But it wasn't on the dots. Yeah, so my name's Paul Anguiano. Haven't been to Full Stack in probably a year. Let's see. I have already canceled trips to to the Olympic coast, to the peninsula, and to Montana and to Northern California. So probably which one I go to will depend on when I'm allowed to go. I don't watch much, but I started watching some episodes of The Outpost, the TV show, not the movie. And other than that, I'm just working for a big hospital system.
Cool.
Cool.
Thanks for joining. All right, I think I leave Bryce and Chad.
I guess I'll go. So my name is Bryce. Guess my next trip, probably back home to Australia, see the family. What was the other question? Oh, binging. It'd probably have to be a lawn care YouTube channel. I've recently become obsessed with my lawn, and that takes up a lot more of my time than I'd like to admit.
It's a healthy obsession.
Yeah, it depends who you ask.
Yeah, during the pandemic, I've been getting a lot of yard work done, probably twice as much as I have in previous years.
Figuring out fertilizer is still kind of an enigma to me, too. I'm like, how often, what kind, there's all these different types. All the information on YouTube conflicts with each other. Yeah.
NPK. You get
Yep.
3400 or 383 or
16, 16, 16. Yeah. There's a bunch of different.
The artwork sucks.
All right. So we'll have someone do a tech talk on fertilizer maybe next week or next month then.
Totally. I would be in for that one.
Yeah.
Bryce, can't you go back anytime you want? Aren't you?
In what context?
You're still a resident there, right?
Right. In terms of like citizenship status and residency status, I can. But with everything that's going on,
In terms of COVID, I'm sure they're like no Americans are allowed.
yeah,
back in
no, I'm
here.
sure if they even knew I lived here, because I don't know why they didn't seem to do anything different to the US in terms of like the way they handled it, but their cases, like their infection rate and their death rate, are unrealistically low. I don't remember the numbers, but it's not anything like.
You can tell if the testing rate's too low when their fatality rate is like 10%.
Yeah.
It's like, yeah, you guys aren't doing enough testing.
Yeah. So Chad, I guess.
CZ. Chadster. You're muted.
He might not even be there.
Yeah, he might have walked off. So
It does say connection lost on his top left.
Okay.
Gray bars.
Oh, I see that. Okay, well let's continue on then, and we can pivot over into the meat. Let Rick get started.
All right.
Yeah, I think that was everybody. Go ahead, Rick.
Sounds good. Let's select.
I'm actually so happy that this year it was on July 1st because previous years has been like July 3rd or July 4th, and it's not been that great. Next month is August 5th.
Yeah, don't like that. Let's try this again. That.
Your cat's so majestic back there, Jesse.
We're in the Matrix.
Now, paw down.
Looped.
That's just really
Hey,
cool
I
to
think
watch.
got some major feedback there.
Let's just stare at this. I'd rather just keep watching this.
I hope I got that on the
Cool.
recording because that is cool.
All right.
Bit
So
of a
anyways,
delay there. Wave your hand.
now here's the hoping this actually works. All right. So can everyone see this? Okay.
Yeah, I can see that. Just presenter mode or whatever the
looks
other
good.
thing was.
Okay. I'd like to get rid of this stupid presenter bar. I have a hunch I'm not going to be able to get rid of. That's annoying.
There's a really subtle arrow on the bottom, bottom right of it, and it looks like you can tuck it. I don't know if you see the same thing that I see, though.
I see no such thing.
Should be able to just hit present, or will it not?
Maybe. Oh, thanks, Google. Annoying. All right. Well. Okay. Well. Apparently.
Is there no option to go full screen on like the menu bar?
Yeah. Well, I think that fixed it. Whatever that was. All right. Okay. So this is going to be a quick topical overview. I'm afraid there's going to be no PhD theses handed out over the course of this talk. Yeah. So we're going to be talking about WebAssembly and a little bit about Rust and a rather unique application, which I think has incredibly practical and immediate real world application, which we'll be covering at the end here. All right, so firstly, let's talk about WebAssembly. So the official definition, according to the WebAssembly Task Force, is it's a binary instruction format for a stack-based virtual machine that is designed as a portable compilation target for programming languages, enabling deployment on the web for client and server applications. All right, so let's unpack that. Well, firstly, that's the boring definition, but really what WASM is rainbows and unicorns. And it will actually solve all of your problems. And it is, in fact, the silver bullet. All right, so
we're still on slide one,
yeah,
Oh,
Rick.
am I?
Well, from our view, I don't know what you're seeing on your screen, but we're still on slide one. Now we're on slide two. Now we're on one.
Okay, so interestingly, so when I hit present, it creates a new window, and
So on the Jitsi here, if it's running anything like it does on the Linux one, what you should do is unshare your screen, hit present, and then reshare the screen and bind it to the new window it created.
sounds awesome. Let's try that. Right. Okay.
Back to just camera.
Camera one, camera two. Camera one.
How old do you have to be to get that Wayne's World reference? Or was it a Wayne's World reference? I don't know.
Excellent.
Right, so let's try this. Share.
Do the presenter and then share from Jitsi and bind. Yeah.
Okay.
Perfect. That
we go.
did it. Yeah, we see the full screen.
Sweet.
There you go.
All right, cool. All right, so just all that stuff that I said before, just repeat that in your mind, and away we go. All right, so WASM's binary instruction format for stack-based virtual machine. WASM is designed as a portable compilation target for programming languages, enabling deployment on the web for client and server applications. And what they really mean is WASM is rainbows and unicorns. And it's true. It's actually pretty awesome. All right, so let's talk about the actual official definition a little bit. So binary instruction format. So as you can probably guess, it is a virtual machine format, and it's tightly packed, whereas all of your control codes are actually just numbers, and basically it gets down to a theoretically minimal size of a program, and it can actually be compiled pretty tightly because the instruction set is actually pretty small, and it's also architecture independent. So it leaves a lot of interpretation up to, well, the interpreter that's interpreting it. So
I have a quick question.
Yeah.
Is this some type of like a CPU emulation that's like encapsulated into like a virtual machine emulator, and then they're just waiting for like people to write high-level compilers for it?
Yeah, basically, right? So as per the next part of the definition is on a stack-based virtual machine. So yes, so basically it is a instruction set for a stack-based virtual machine. This virtual machine is actually installed and running in Safari, Firefox, and Chrome right now. So if you were to write WASM, you could actually target any of those browsers as well as a bunch of other platforms. So yeah, at the end of the day, WASM is basically just a standard, right? An internet ratified RFC that describes this instruction set for virtual machine.
How does it present? Can you make a website that they visit, and then when they go to that website, you get the Rust or the WASM thing, or do you have to actually go file open and then there's like a binary package on a local disk you have to open?
No. So it's actually neither of those. It's actually pretty much rendered transparently like JavaScript is, right? So if you have JavaScript enabled and the site has WASM, it will run the WASM as well.
Got it. Okay, but it's still you're going to be sandboxed the same way most browser code is,
yes.
where
it
you
is
can't
absolutely
access the file system, etc.
Yeah.
Okay.
So when you are running in a runtime like V8 for Node.js, or if you are in a browser, then yeah, you're definitely going to be sandboxed. So you have actually fewer APIs at your disposal in WASM than JavaScript at this point, but they're trying to close that gap. So portable compilation target was the next thing. So if we go back and actually look at the real definition, right? WASM is designed as a portable compilation target for programming languages, enabling deployment on the web. Right. So portable compilation target means that it is a architecture agnostic compilation target, and the interpreters can be anything, right? So the other thing to note is what WASM, at least for me, as someone who's done a lot of systems programming and a lot of JavaScript programming, I hate with a capital H and an 8 JavaScript types. The number being the universal format for all types of numbers that are integers or otherwise, with a really weird cutoff between when it acts like an integer and when it acts like a floating point value, is really hard to work with when you're trying to do things like create unique IDs and other stuff like that, or get high precision numbers or currencies or anything like that. So basically, WebAssembly offers much more of the low level intrinsics that you would expect in a systems level language, such as I can actually say I want an 8-byte character or an 8-bit character, or a 64-bit float, or a 128-bit float, or 128-bit atomic. You get a lot more. Basically, you just have a lot more control, I guess, right? And of course, that's also up to the language that you're using that is compiling into WebAssembly, right? So, right. So, and they did say client and server, right? So what I'm going to demo here in a bit is actually going to be demonstrating some server-side WebAssembly, but client-side WebAssembly is totally a thing. Obviously, I'm going to show you something kind of cool along those lines as well. And then, of course, platforms as well. So people are looking at this as targets for Internet of Things. So basically, instead of having to compile, right? So in many ways, WebAssembly for some is realizing the dream of Java. That is to say that you can actually compile it once and run it anywhere. So you could basically have x86 platforms. You could have Atom. You could have ARMS. You could have a bunch of a sensor network. Obviously, they got to be pretty beefy things. We're not talking little tiny real-time operating systems, but for larger units in multiple architectures, you can basically write code once, compile it, and it will literally run anywhere. Right. So some awesome use cases. Serverless. So think Amazon Lambda, Cloudflare web workers, which I'm going to show you. People have been using this, so there are dynamic routers. There's a plugin for Nginx that will let you drive Nginx's routing logic if you got some complicated stuff using WebAssembly. I know Fastly and a couple other places are building, language agnostic runtimes for basically similar things to like Lambdas. User-defined functions in databases. Some of the new NoSQL databases coming out, like a lot of the streaming analytics servers, will let you define queries in WebAssembly. So basically, they give you the API. They don't care how you implement the API, as long as it's WebAssembly and it's calling those functions that they invoke. So some cool stuff. Obviously, custom middleware if you have your own internal, your enterprise-y routing logic or whatever. Library integration. The fact that I don't even know what the count is now. I think it's over 30 different languages can now target WASM as a compilation endpoint. Means that you can actually write libraries in WebAssembly and consume them from other things, maybe or maybe not written in WebAssembly, right? So because you can actually link a WASM runtime to your application, and now you're free to run other WASM things. Obviously, cross-platform desktop applications is something I'm really excited about because I hate Electron. Like desktop Slack is awful. And frankly, we just don't need, I mean, if you actually think about what it is you need out of, a programming language and a GUI app, you really just need a web view and WebAssembly. And that should be it. You should be good to go, right? So we should start seeing a lot of much lighter weight desktop applications built using some of these new GUI frameworks that are out there. Let's see if I can actually pull this. Can I actually copy this? Oops. Let's go over here. No, it doesn't let me copy.
According to Apple, iPhone apps will just run on the Mac in the future.
You know what? Apple can die in a fire.
Love it.
I guess you're not
Amen, brother. Amen.
Fan of their silicon, I guess.
Yeah. So hang on. So let me just see if I can pull this guy up because this is fun. Let's see. Actually, I might have to reshare my screen because of sadness. Oh well, yeah, we'll pull that up later when we're looking at it. But basically, this link here is Doom 3. Doom 3 was ported to WebAssembly in C++, compiled and targeted to WASM using the mscripten compiler or recompiler. And it's fully playable. You get between 30 and 60 frames a second in my web browser playing Doom 3. So that's kind of cool. So full-on cinematic video game action is totally a thing with WASM because of the efficiencies you can achieve over JavaScript in browsers. Right. So what's it look like? So, and I did mention there was a binary interchange format, but there's also a text work-alike so you can basically take any binary VM language and kind of unpack it into this text-based VM language, and the results are somewhat the same, right? Obviously, before you execute, you have to repack it. But so it's actually, in this format, it's fairly readable, right? It just kind of looks like Lisp. So you could, when you're working with it, you can just pretend that it's binary Lisp, and you're probably not too far off. So I'm not going to get too much into the details unless people want to about actually how it's implemented and all that stuff, but just kind of at a high level, just more about what you can do with it. So the limitations, obviously, so sandboxing, because, remember that part where we talked about this is a binary compiled language that you're running on everybody's, machines. Obviously, security is first and foremost the priority. So, it was designed with one thing in mind, and that is to safely execute on every browser. Therefore, both the design of the virtual machine language itself, as well as the sandbox around it, is pretty secure. So pretty much a WASM module in a browser has access to literally nothing, right? It literally can't do anything. It has to be handed either what they call tables, which are kind of like this array-based memory. Think of it kind of like as an IPC or an RPC mechanism between WASM and your JavaScript workers in your web browser. So you can basically pass messages back and forth that way. You can also pass function calls back and forth. So your WASM lib, right? So you're just making a lib or a module, can export any number of functions to the browser, and the JavaScript in the browser can call those functions, and also the JavaScript, when it's staging the WASM modules, can hand any functions it wants to back to the WASM code as well. So what this means is, I think I talk about this here. So direct writing to OpenGL and Canvas isn't natively possible. It takes some setup and teardown, or mostly some setup in JavaScript, where you actually have to create all of the resources that are going to be shared and pass the relevant functions over to your WASM modules so that it can write. So even though you have to go through this like message passing barrier, it's still faster than JavaScript because of the speed at which the WASM modules can compile. Plus, you just gain quite a few optimizations around being able to work with native data types, especially when you're talking about like OpenGL and shaders and stuff like that. So there's lots of really cool. I'll send out a bunch of links with resources to building video games in WASM and building. There's a couple client-side GUI systems now that are in Rust that we can go over if anyone's interested. Anyways, so yeah, still very useful for graphics, very useful for anything that requires a significant amount of number crunching and logic. So there's a lot of data science oriented groups, either in Julia or Rust, that are using WASM in the browser for like large scale data manipulation, which is kind of cool. And so yeah, so what I'm going to do is actually just kind of show both how you can use WebAssembly. So you can basically drive Cloudflare's workers, which are similar to Lambdas in AWS. You'll be able to drive Cloudflare workers with your language of choice. Obviously, your language of choice is Rust. So that's what we're going to talk about now. So I'm just going to do, again, a quick overview of Rust, just so you guys have some context for what it is. I'm going to be showing you here in a second. So Rust is, if you're unfamiliar, was originally intended to replace C++. And the vision for Rust was a kind of building a new way of statically analyzing and compiling programs to eliminate the need for manual memory management, while also not requiring garbage collection or anything like that. And the way it does this is it basically analyzes the scopes and the lifetimes of every object that you create, whether it's on the stack or on the heap, whether you allocate it dynamically or whether it's compiled in. It understands the lifetime of every single variable that you're working with. And if it can't know the lifetime, it's either going to yell at you, or if you're treating the lifetime incorrectly, if you're trying to pretend that something is going to exist or live longer than it really does, it's going to yell at you. If you try to delete something manually, but other things are still trying to use it, it's going to yell at you. Basically, the Rust compiler just yells at you a lot. But the advantage of this is once it stops yelling at you, once you've convinced it that your program is safe, like the odds of it working the first time, like running and working after it compiles, is very, very high, right? So so you're basically trading like compilation and compilation times. Right? I guess you'd say your debugging happens when you're compiling the source and not in runtime in production, right? Because like odds are, if Rust let the program compile, it's probably doing exactly what you intended it to do. Whereas if you contrast this to some dynamically typed languages, any of them will let you, typo a variable, set a value on something that doesn't exist or something that you're never going to reference again. And it's perfectly okay with that, right? So you can do some really asinine things, and it'll work just fine until you hit that particular branch in production, and everything goes to heck. So Rust is kind of nice in that, if you kind of, I don't remember exact details of this, but anyone's probably seen these things about where you, in what stage in your software development lifecycle you catch errors. The more money you save, and the more time you save, and the more frustration you save. So like if you catch an error at requirements gathering time, it's going to save you 1,000x worth of effort as if you found it at production time, right? So basically finding all these bugs at compile time is actually, I've found a huge win for productivity. Even though, as you can probably guess, Rust is going to be a little bit more verbose than some languages, although surprisingly not as bad as C++ in my opinion. But it's going to be more verbose than a dynamic language. But yeah, the additional effort writing source code is still saving you time and money in the long run, in my opinion. Actually, it's not just my opinion. There are actual real facts backing that up, which I can also supply to you if I want to. Right. So unique Rust features: there's no garbage collector and no runtime, but it's almost completely memory safe. So this is important to point out. So no runtime is kind of critical, and it's why a lot of web developers have actually come to the Rust fold, is because they originally started using Rust to be able to optimize some critical paths in their server-side code. So one really good example I remember was there's a company called Tilda, which does like streaming data. They're like a what would you call that? Like a web data collection tool, right? They're a Ruby shop. It was started by White Cats, Yehuda Katz. And so he's a famous Ruby guy, right? He's the guy who wrote Bundler and a few other things. So big in Ruby. They built their server side in Ruby. Obviously, they were unable to scale some parts of it because Ruby is as fast as Ruby. So they were looking for ways to, in a low risk way as possible, optimize some of these super tight loops that they had where they're processing these huge amounts of data. So what they were able to do with Rust is create a native compiled library as an extension to Ruby, and link it in and get like something like a 200x speed up without risking, without taking the risk of having rampant, random memory induced security vulnerabilities or crashes or whatever at runtime. So the web devs have actually found a nice niche there, because they're afraid of C and C++ because of the security risks and having to manage pointers and memory allocation and all that stuff. So it solves those problems while still protecting people from the memory issues. And also, it turns out that Rust's borrow checking semantics that it uses to guarantee memory safety can also guarantee concurrency safety. So you're actually free to write multi-threaded programs. And again, the compiler is going to yell at you if you do something that doesn't make sense according to its semantics for how you're supposed to structure a program. So it can't say that it's always deadlock or live block free, because some things are perfectly sane from a compiler's point of view. But for the most part, almost all of your traditional mutex, or all of your traditional multi-threading errors and concurrency errors and race conditions are going to disappear because Rust is enforcing these additional safety semantics. So it's got the advantage that it's basically a systems level programming language. It gives you systems level speed, but it's kind of got mittens on, right? So it's kind of cool. So yeah, so as I mentioned, there's a simple scaling path for server-side apps. It benchmarks as fast as C++. That's kind of where its intended target. Obviously, somebody can go crazy writing super optimized C with WASM, and they can get faster than Rust. But for the most part, it's definitely within the same order of magnitude of just about any C or C++ compilations. But it's got much higher level programming language semantics as well as the standard library. So you're going to find when you're coding in Rust, you have the option to treat it much like you would see Ruby or modern day JavaScript or TypeScript, where you're leveraging iterators and streaming with combinators on those iterators, rather than kind of that old-fashioned imperative style of programming. So there's actually some really sweet high-level language adaptation libraries that make it even easier to create extensions in both directions for Python, Ruby, and Node.js. So these would allow you to create interop tools in any of these languages in a very friendly, kind of idiomatic kind of syntax. And it's actually built into the Rust language using macros. So it's very, very easy to actually take any of your libraries that you're building in Rust and turn those into Python, Ruby, or Node.js extensions, or Lua, or any zillions of other things, right? So, all right. So all that intro aside, what does it look like? Can everyone see this all right? Is this readable?
Looks
Good
great.
here.
Yep.
All right, cool. So in Rust, you're going to find there aren't any classes in Rust, but there are interfaces, which they call traits. And so it's a trait-based or a concept-based programming language. It doesn't use classes and inheritance, but you'll find that you pretty much don't need them in their style of programming. And there's been an ongoing war in GitHub issues about introducing inheritance to Rust, and there's a significant amount of resistance because typically everyone who requests this, they just don't understand Rust and how it works. And so I think pretty much these days everyone kind of understands that if you're inheriting, you should be inheriting to match interfaces, not necessarily because you're trying to kind of sneak functionality into things. So anyways, so if you got structs are, as you can guess, just collections, right? They're kind of logical groupings or logical and physical groupings of data, right? So here we have a point. I've defined this point as a floating point, 64-bit floating point of X and Y. Here we have a rectangle that has 2 points, a top left and a bottom right. Here I have a function. So fn print rect, that's the name of the function. So in Rust, we've determined that the important part of function parameters is the name of the parameter, and the type is less important. So the name comes first, and the type. So you'll find that if you're familiar with TypeScript, TypeScript ends up looking an awful lot like Rust. It's just because modern languages have kind of started to converge in this same kind of style that's like quasi-functional, heavily inspired by ML. So basically every function has a main, every program has a main or has an entry point by default. In x86 systems, it's called main. If you're in WASM, you get to define what your entry point is called. Obviously, if you're in smaller embedded systems, you get to define the entry point there as well. So basically, there's lots of nifty intrinsics in Rust. We've got like a range operator. So this basically just the for loop is for I in 1 through 3 do this, right? So basically, I want to get rid of that stupid. Yeah, there we go. All right, so basically, this is kind of a boring program, but it gives you the point. So we're basically looping 3 times. We're creating a rectangle 3 times on the stack, and then we're printing out the rectangle. So what I've glossed over here. So there's something called this hash thingy. So these are decorators. So Rust has an incredibly rich macro system that lets you define basically meta programs that do really cool stuff for you. So there's a lot of what we call auto derivation traits, right? So a trait is basically an interface in TypeScript, if you're familiar, or an abstract base class in Java, or an interface in C#. Basically, it says that this thing must have these methods or these properties in order for me to consider it having this trait, right? So a debug trait is something that basically lets me call, actually debug on it. And where this is useful is when I want to print out debug output by using this special syntax that's : right? So basically what I'm doing there is saying I want to print something. I want to print the debug output of R, right? And since R is a rectangle and R derives debug, so I basically auto-derived the debug trait without having to actually implement the interface myself. I'm telling the compiler, hey, you implement this interface for me because it's all boilerplate and I don't want to do it. So Rust has a really cool way of just eliminating lots of boilerplate while allowing you to have lots of like widespread interoperability and things like that. So basically what we're saying here is point is debuggable, or point can provide debug output, rectangle can provide debug output, and then this print rectangle is relying on the fact that it can provide debug output. So if these weren't there, this program would fail to compile because R does not fulfill the debug trait. Anyways, so I probably went too far into that, but the short story is Rust has, it is a systems level language, but it has some sweet, super modern ways to make your code look really, clean and succinct and elegant. And it's very extensible and yeah, very, very powerful. All right, so that's enough about Rust for the sec. Let's talk about the last piece before I start showing you some code. So WASM bindgen is a tool that basically packs up your WASM code, or also conditionally compiles your native code into WASM code, kind of packs everything up and does all of the adaptation and marshalling that makes it interop with that will make it interop with JavaScript in a WebAssembly context, right? So WASM bindgen, I'll show you in a second, is basically where all of the ugly stuff that you don't want to think about, like hey, this function needs to be exposed to the runtime as having 3 parameters and this name and this return type, right? All that stuff that nobody wants to deal with, but you have to when you're talking about interop libraries. So WASM bindgen just kind of does all the stuff in the background for you and generates some native code as well as some JavaScript code to kind of glue everything together. And we're going to kind of see pieces of that in this example. All right, so the demo that I'm going to do is well, I'll show you in a second, but basically I have a set of workers in Cloudflare which perform an incredibly important task. There's basically so Cloudflare workers are basically serverless. They're not like Amazon Lambda, which runs a Node, like a full-fledged operating system environment, or almost operating system environment with the full frameworks of like Node.js and Python and Java. Instead, they offer a very, very simple interface. You basically get what is effectively just web workers API in a browser, if you're familiar with that. And that's it. Like, that's literally your runtime. So the only runtime they support is what is effectively just like a JavaScript, like SpiderMonkey. Actually, I don't even know. I don't know if they actually run SpiderMonkey or V8, but basically you just get like a JavaScript engine, and that executes all of your code. But they do support WebAssembly, which means now we have a much richer API to draw from in terms of functionality. And then also one thing that we'll see real quick is that Cloudflare does supply a CLI tool called Wrangler, which does a really good job of kind of like doing all the plumbing for you. So it makes it easy to just get straight to the work, and that's it, right? So all that said, I'm going to unshare and reshare back to my terminals. I think apparently it doesn't like my microphone making noise. Interesting. And right. So let me unshare. Okay, share again. This time I'm going to see if I can, yes, share that. Okay. So everyone see a terminal?
Looks good.
All right, cool. All right, so as I was saying, there's a critical missing piece of functionality in Slack, and that is the ability to flip over tables when you're angry. So basically, what I've done then is I built a tool in Rust, and we can look at the source code. Here, and we can see that I have a pretty small, so it's about 50 lines of code all in utility, but the important part is here, right? So basically we have some emoji or some Unicode table flipping action happening. And what I want to be able to do is actually type, when I'm in Slack, I want to be able to type flip, my slash command, and I want to be able to flip over a table at random, right? So how does this work then? So Slack slash commands, if you're not familiar, the easiest way to do them is API driven. So you can create an app in Slack. I can show you that if you're interested. But basically, you can create an app that is nothing more than a slash command that's tied to a invocation of a remote API call. So thanks to Cloudflare and Workers, I have this module serving a REST API on the internet that will return a flipped over table at random. Luckily, it lets us write in Rust. So there's a couple things I want to show you.
A little more of a definition on flipping over a table. Do you mean reversing the order in it or displaying it?
No, I mean like actually. Well, here let's just.
It's like a emoji when somebody says something that pisses you off in chat, you flip over the table, which is basically just one of those sequences of characters that looks like a guy lifting up a table and flipping it over.
Oh, hold on. So we're talking about triggering some sort of graphic or something.
Yes, right. So as an example, can I make this bigger?
It's like when you rage quit a board game and you flip over the table.
Yeah. So basically, the functionality is as follows. I type flip in Slack, and it flips, right? So, and I find this incredibly useful.
Your screen share is down. We're just seeing your camera.
Oh, I see. Right. Yeah.
Okay, so flipping over a table is not a programming term. I thought we were talking a programming term here.
Yes. Yeah. Which we are talking in programming terms. I definitely should have disambiguated there. Yeah. Let me see. So apparently.
Okay, so you kids in your Slack, so flipping over a table in Slack back in my day, Slack was a distribution of Linux.
Yeah, no, this is like the chat platform when something happens that it annoys you, rather than flipping them off. Yeah, like look at that. See, it looks like a guy with two arms throwing a table over.
Okay, so this is almost a substitution. We're talking now a substitution of text when you do the flip.
Yeah.
Okay.
Yeah.
And his randomly chooses one of 8 different, slightly different looking table flip.
Okay.
So interestingly, like I actually managed to get 3 of the same in a row, which is cool. Yeah. So I think
this would be able to be done on the Confluence Slack if we installed it.
We should totally install this in Confluence Slack.
Yeah. So yeah, flipping over tables. I do it often. You can ask Devin. But luckily nowadays I don't have to actually flip over tables, which is good. All right, so let's unshare that. Okay, so that's what I mean when I say flipping tables, right? So we're basically just creating a Slack app that makes a remote API call. So here's my random emojis. This is my selection of random emojis. So basically what I'm doing, anytime somebody hits my web service, I randomly select between one of these emojis, or not emojis, but Unicode.
You're not
Unicode
sharing
animation.
again.
Yeah, we're just seeing you. We're not seeing your screen.
Yeah. All right, let's do this one more time. Okay, top. There we go.
Jitsi screen share is finicky like that. Yep, it's coming through now.
I mean,
Working now.
Well, it's subject to Firefox's screen sharing capabilities as well, so it's kind of limited. Right. So
you get one of those 8 basically.
Yeah, exactly. So one of these Unicode, I don't know what you'd even call it, ASCII art gets selected. Yeah.
So this is a totally random question, but the assembly systems that I've worked in previously, one of the things that was incredibly difficult to do was just generate a random number. I'm assuming in Rust and WASM that's easy.
Yes. Yeah. So so you bring up an interesting point though, and that is that in a what's the word I'm looking for? A platform independent context, you don't get to rely on the standard library, right? So if you're familiar with programming in C or C++, or even Go, or any of the languages that have native compilation, and even others, standard lib provides a lot of really useful things for you, such as terminal emulation and random numbers, threading, et cetera, et cetera. So if you're building for a complete platform independent setup, then you do not get to expect that a standard library exists. So Rand then, so there is in fact libraries in Rust that are implemented in a platform agnostic way. So this does not rely on any. I mean, there are random number generators that can use like Linux's random number generator if you want to, but for the most part, obviously when you're using WebAssembly, that's not really an option. So all I have, what's available to me is anything that can compile without the standard library, which is still in Rust a huge amount of stuff. So interestingly enough, I do not have a global allocator in WebAssembly land, right? So one thing Rust definitely does expect is when I want to dynamically allocate memory, that it's just going to call the system's malloc, function, basically, in a nutshell. And that doesn't exist, right? So what we're actually doing is this little chunk of code here is actually swapping out my allocator with a silly allocator that basically just understands how WASM's array-based table allocation works. So this could run in a browser just as easily as it can run on a server, basically.
Well, you really look intrepid there.
Oh, so I think Trevor activated a screen share that says that's some high quality entropy with Waterboy Adam Sandler there, which I agree with. But if you click on Rick's name, you'll go back to his screen share because you can have multiple screen shares active at the same time. So click on Rick's name and you'll pop back over to his WASM or his Rust code.
Yeah, I didn't mean to take focus. I just wanted to sit here in the background with some high quality entropy.
I like it.
Nice. High quality entropy is definitely an important topic. All right. So basically, the core of this entire function is quite literally just this function. So I'm remember what we talked briefly at the beginning about having to marshal functions between WASM module land and JavaScript land. So that still applies in web workers, right? Because I'm basically just, this code, this module right here will literally work just as well inside of a browser as it will anywhere else. In fact, I should probably, put the glue code together just to do just that. But basically, so I create a random number generator, and then I use choose, which is a method that's on the trait of arrays, right? And choose takes a random number generator and then returns me some random subset, right? So this is an array. This is an array of strings, basically, array of Unicode strings. And when I say graphics.choose, choose is a method that just is present on every array in Rust, thanks to the array trait. So I say array choose. That actually might be due to, yeah, it's actually because of this trait, slice random. So this trait is actually what is implemented for arrays, and it makes arrays randomly selectable. Anyways, so, and then from there I map, which basically saying, assuming that I've been given a result, I take that result and I'm going to make a response, right? And so this is where Slack, I'm structuring this, is basically a JSON response in a way that Slack understands. So Slack expects to see a response type, text, and attachments as a bare minimum of any app that is returning, or like any web service that's returning any web service endpoints returning whatever output it returns it, whatever. Anyways, so this struct, so as you can probably guess, has some cool features. As we already talked about, it derives debug, derives clone, which basically means this is copyable, or clonable specifically, not actually explicitly copyable. And then more importantly, it also derives serialize. And this is where it gets kind of awesome, because what it's doing right here is generating all of the boilerplate code necessary to turn this guy into any number of wire formats, including JSON or anything else I tell it to, right? So this basically tells it this struct to basically describes how this struct can be broken down and emitted over any number of serializable formats. So that's another big win. So I don't actually have to I don't have to like manually spell out, okay, this next field is response type and it does this, and this field is this and it's this, right? So it's kind of cool. So that's what this guy does here. So basically I'm calling, let's see. Yeah, so basically I've constructed the struct here, right? So this is a Slack specific enum there. The text, this is the actual table flip picture that I've chosen. And then this is just an empty vector, whoops. And then, so basically what I do is once I've constructed that struct, and then I use Sirity, which is our Sirity stands for serialize, deserialize, but it's a specific WASM bindgen version. And this actually returns the JSON value that I'm expecting. And that's literally it. That's all of the functionality. I do have an index that actually returns a bat. Why? No real reason. Okay, so basically this module, like this will compile down into a library, and it will really only emit two functions, and that is flip and index, right? And these are also decorated with the WASM bindgen proc macro decorator. And as I mentioned before, these decorators do really cool stuff for code generation. Well, this is where WASM bindgen generates all of that marshalling and unmarshalling code that's necessary to make this thing play nice with in a WASM, in a WebAssembly environment. So there's one more piece we can look at, and that is kind of the glue code, right? So as I mentioned, only JavaScript runs in Cloudflare Web Workers. What we can do is we can actually look at the worker.js. So this is the bare minimum Cloudflare worker function, right? So basically, so when I said that this thing has only a web, like a browser, like a JavaScript DOM style, or not even DOM, but a JavaScript API interface available to it, and that's all, that's really it. So we are literally using the native, browser method add event listener. And what we're doing is we're waiting for a fetch event. And this is something that Cloudflare invokes on our module from the outside anytime there's a request to our web worker, right? So if somebody's making a request to my domain, my URL, then it's going to invoke this event. I choose to respond to it by basically calling this special. This is specific. This is special for Cloudflare. Respond with basically. I handle requests. So this is going to look like, if you're familiar with Node.js or like pretty much any modern web framework on the planet, this is kind of just a RESTful style method that returns HTML, right? Or JavaScript or JSON or whatever it might be. So in my case, it was returning JSON. Okay, so this is how we would interact in a browser, right? So assuming that I've basically loading my WASM module, I'm given this special context called WASM bindgen that's kind of preloaded into the JavaScript. I can show you how that happens in the background. It's kind of ugly, but it works. And basically, I'm just taking my exposed method by unpacking it using pattern matching. So I'm taking the method flip that we defined in Rust. This is basically this is just kind of loading all of the necessary WASM module stuff. This can actually be done out of band. This doesn't have to be done for every request, but I was lazy and I just did it here because it really doesn't matter. And then so basically, so I call flip, right? I call my flip function, which generates my JSON response, and then I stringify that. So now I have a string. I respond with a 200 OK. I'm responding with application JSON, and away it goes, right? So if we wanted to, we can see that I'm just using the workers.dev domain, which is just a free domain. So this is basically hosted for free on Cloudflare because I'm cheap. So if you're OK with having a workers.dev domain, you can have all the workers you want within reason, I think. So I basically just have a subdomain called flipwasm.unruly. And so if I make a curl request to that, you see my JSON response comes back. So this is the flip response struct that has been converted to JSON. As you can see, the text field is this. And we keep doing this. We keep getting random responses. Yeah, so that's basically kind of the high-level tour in a nutshell. I'm a big fan of choose your own adventure style presentations. I'm curious to know.
I gotta say,
if
you do too many in a row, it looks like you get the same response 2 times in a row.
Yeah, so I managed. So there's 3, and then actually
there's 2 in a row.
Yep.
It's caching. It's feature.
Yeah, well, I mean, it actually, so
it's
I can't
random,
actually
I guess. I don't know.
Yeah, I mean,
one of the random cycling is running a slower rate than you're refreshing.
I don't know. I doubt it. I mean, I'm pretty sure it's a standard pseudo random number generator, right? Which means that every time you ask it for a number, it's going to give you something way across the number range.
Yeah.
That just gets clamped down into my 1 through 8. So there's
it's random.
Yeah,
we just got lucky a couple times.
Yeah. Randomness is, showing the same thing a dozen times is technically random. You can't prove it's not, right?
Yeah.
So I think there was an XKCD about that. So so basically, when going back to my Slack / command for flip, when I hit flip, basically my app in Slack, I use that with a quote unquote. I can hit this in a web browser too. So my app will basically just hits the same endpoint and renders the results. So yeah, so I can show you guys how Wrangler works. I can actually, what we can do is look at the actual plumbing in the background that was created by BindGen. There's a couple pieces that are interesting. So utils is one. Yeah, that one's actually less interesting. But if we look at the worker, I think it's generated script. So this is the actual complete script that gets run. So basically all that WASM BindGen was generating some adapter. So this is all JavaScript. So the WASM BindGen was generating this some adapter methods to kind of like map Rust idioms to JavaScript idioms and back, like get array U8 from WASM, and then string encoding. So basically just some adapter stuff, debug string. So init. So this is where we're actually like the rubber actually meets the road. This is the WASM BindGen generated stuff. So it's, yeah. So, I mean, if you actually look at it, this app is still technically like, 80, 90% JavaScript and only like, 20% Rust, but that's okay. I still like it. Yeah. So we can look at, I guess now that I'm done with that demo, we can do, there we go. That is some high quality entropy right there. All right. So what I want to do now is go see the, hang on, I'll share my screen in a second once I can figure out where I'm going with this. There it is. Okay. So I think I can just, there's the random number. Yeah. All right. So I'm going to steal the screen and just do that. All right. So, so this should be fun. Can everyone see this all right?
Yes, I'm receiving it fine.
Cool.
Looks good here.
Right. So this is literally Doom 3 recompiled in, oops, there we go. So for some reason I get this mouse drift. I'm not sure why that is, but yeah. So basically this is a working Doom 3 running 100% in my browser, courtesy of WebAssembly and the mscriptin compiler. So if anything can demonstrate what kind of performance you can get from WebAssembly, this is definitely it. So yeah, so I guess, I don't know, we can stay here and watch me play Doom 3, or I can.
Okay, so the performance is great there. So I presume it sounds like, though, implied the security is going to be pretty decent because it's pretty much sandboxed within the browser and has to be brokered through. I mean, this really doesn't sound like it's going to be a vector for the Indian hackers and crap like that.
Yeah, that's, I mean, that was, yeah, the primary goal was definitely just that, right? So, that's not to say that somebody couldn't invent some sort of, what's the word?
Some sort of
special combination of instructions to try to escape from the VM, but you've got a lot of sandboxing and a lot of, basically you have a lot of stuff to escape from. And I don't know if anyone's actually successfully, no, that's not true. There have been a couple early on, there were definitely some successful penetrations of the system, but there hasn't been one recently as far as I know.
But for the most part, it's probably even better than the Java VM in terms of security.
Yeah, like so far, that is very much the case. And I think largely just because it's relying on the browser's sandbox, which is, kind of a time-tested, tried and true security mechanism both in Firefox and Chrome.
Cool.
So, yeah. Yeah, so I guess that's pretty much my presentation. Give me 1 sec. I actually have to run and rescue my animal. And then I'll take some questions or cover some additional stuff. All right, I'll be right back.
Sure. Yeah, no problem. So, guys, while we're waiting for Rick to come back, Michael had to jet. He wanted me to mention, and I can recap this again later, the next full stack after today will be on August 5th. Same place, same time. We will send it out on the normal distribution channels that we have, but August 5th, 6:30 p.m. And I think we're going to keep going with Jitsi for now. If you guys have any feedback, if you'd like to try a different platform or something, let me know. We're recording this a shot, and we'll see how that works. But if you guys have any feedback, any thoughts on if Jitsi seems like it works okay for you or not, or if you prefer a different platform, make sure to let us know, and we can take it under consideration.
I think Jitsi works fine.
Yeah, it seems like it's working well. I'm actually watching. It's running as a virtual machine here at my house. I've got a little server rack, and I've been watching it performance-wise just with CPU and the amount of network traffic going. We're averaging right now around 8 or 9 kilobits per second throughput, and it seems like it's working well. I haven't heard really any bad audio distortion or jitteriness or anything that couldn't be attributed just to normal variances in people's internet connection. So I think it's been pretty reliable for us. Welcome back,
Yeah,
Rick.
I think.
Oh, go ahead.
Yeah. Hello.
Cool. So yeah, if anybody has any questions for Rick, I'd say fire away.
Whereas JavaScript and some of these other things seem to have now database access within the browser, does WebAssembly get some of that access too, or is that passed through the same JavaScript brokering that you've already described?
Yeah. So basically, the WASM modules can have access to anything that has been handed to them by JavaScript. So you can take the handles to the database, like the KB store inside a browser. You can basically be handed a reference to that by the JavaScript and then start operating against it.
So you basically hand the reference, and then the JavaScript doesn't need to do any more. It just it sets up the connection, and then the WebAssembly can continue to turn away. Okay.
You have to be able to you have to be able to define those handles in terms of functions that your native code understands.
Yeah.
So you kind of have to marshal those function calls. But yeah, so you can hand what are effectively just API methods of the browser to your native code in WASM land if you want.
Similar with if you wanted to hand over like a TCP socket, a raw TCP socket.
Well, the browser's not going to let you do that.
Okay. We lost your audio there, Rick. I think you somehow muted yourself.
Interesting. No. Yeah, I just moved my keyboard. Apparently one of those is a mute button. So so the browser will only let you initiate connections according to the browser's strict rules. But where it gets interesting though is there are people creating, I don't want to say unsandbox. They're still sandbox, but I guess less. We'll say a more featureful runtime that's not a browser, right? So I know Fastly is working on one. A couple of the web groups, I think Mozilla as well. One of them is called WASM Time, and it is literally just a server-side runtime for WASM that has more. It just offers a much more systems level set of functionality as a standard library to it. And so you would be able to open up arbitrary TCP sockets and things like that. And yeah, so.
Okay, cool. That answers my question.
Yep.
Thank you.
Yep. Next caller.
I have a question. So, what do you personally use this for in your work, and what was the inspiration for you learning all this technology stack?
All right. So, I've been a Rust guy for 6 years now. Like literally since before version 1.0, I've been part of the Rust project and contributing to the ecosystem. Rust was born out of it was pretty much born predominantly. It was a partnership between Firefox and people at Google, Mozilla and people at Google. So it's been largely managed and run in the Mozilla group, which is also the same group that owns and operates, or I shouldn't say owns, but operates the Rust project as well. So WASM had very deep roots in Rust from the very beginning, and so I was definitely. My interest was definitely mostly from as a technologist, and the utility of WASM in general, and not because I had any specific application for it. Mm-hmm. So obviously, my table flipping exercise was really just to prove that I could actually make something useful with WebAssembly. That said, so. The thing that got me into programming, my dream, my vision of what I wanted to do, was build the metaverse from Snow Crash.
Oh, okay.
If you're not familiar, the metaverse is basically like a collaborative 3D virtual environment. Pick your favorite 3D platformer, but the difference is that each person comes to the environment with their own code, right? So how I render myself is up to me. I actually supply the code to render my avatar, and how I interact in the environment is both a combination of my own objects code that I'm basically supplying to the system, as well as the the constructs code that renders it. In order to accomplish something like that, frankly, it's just never really been possible. Historically, you could probably have pulled it off with Java web applets and Java 3D, but it'd be, really, really slow and mostly unusable and probably insecure. So I think that this is WASM in my mind represents actually probably the first real possible attempt at building something like that.
Yeah.
Right. So now you can have a high performance yet safe system for allowing people to basically collaboratively create graphics algorithms and implement physics from the inside out. So kind of think of it as like Roblox and Minecraft, and all those concepts are all kind of pointing at the same kind of universally extensible environment. So I think, so I'm personally interested in WASM for that, although I don't these days harbor any notions of ever having actual time to implement something like that. But I love the idea. So I have actually used WASM for server-side routing, right? So specifically for custom Nginx logic for deciding when to do some pretty complicated things with regards to indexes and upstreams and finding the right guys and stuff like that. But you have to do it at really high speed. So I know that there's a lot of interest in the CDN space for things like that. There's lots of really cool stuff.
Being more of a infrastructure guy, one application that I see that I haven't seen anybody take advantage of is you see a lot of companies like F5, Nginx has one writing load balancers that need to have layer 7 capabilities where it can actually parse code and then do load balancing features based off of actual JavaScript code, and I can see that potentially being an area of application that I don't think has been exploited a lot yet. So
Yeah.
it's kind of interesting.
Absolutely, and that is actually kind of like the primary use case of Cloudflare's workers is actually to be a front end for their CDN.
Yep.
So at our current startup that Devin and I work at, we're actually we have a worker that's doing exactly that. It basically has more logic than you could apply with just configurations, right? But it's still, for the most part, behaves rationally and like caches all the results. So yeah, that's, I think.
Yeah, and performance is so important in that space, because when you put a load balancer in front of other workloads, you're doing so because the load is so high, but then the load balancer itself can become the bottleneck if it's not performant enough.
Right.
So.
Yep.
Yeah,
and there's people don't think about just how much logic could be executed at the load balancer state, right? At the router level. If we're talking about like JWT tokens, it could do, API gateway rate limiting, right? So if you got a bad actor coming in and trying to DOS your system, you could basically you could implement all sorts of custom logic at the load balancer level. If you
get 1,000 requests as fast as possible for free, and after that we start throttling you by sending you this other route. We load balance, like one that I see in big Fortune 500 IT infrastructure a lot is GLB, like global load balancing, where depending on the region that you're coming from, you get sent to whatever is operating fastest for that, usually the one that has the best global proximity, but that can actually vary if it's got too high of a load. Yeah, there's a lot of inputs that can be taken into account there. It's cool.
Exactly. So, yep. Yeah, I think we're on the same page there. I think that's where I'm. That and user-defined functions in databases, because you're seeing now. So Kubernetes is an interesting one. So Deis Labs, I should have showed this one. Deis Labs has already built a WASM node type for Kubernetes. So not just an operator that runs Kubernetes like serverless, but like literally you describe your workloads to be scheduled in buckets of WASM that are executed as if they were containers.
I was going to say, so it's not an actual Docker container primitive, it's a piece of code that then gets scheduled by the Kubernetes scheduler? Is that
Exactly.
Okay.
Exactly.
So it's kind of your own implementation of serverless, like Lambda or something like that.
But it's lower level. Like I was surprised because I was in my spare time building exactly that. Like basically just a high level loader for WASM modules for serverless that uses the serverless protocol. And then Deis Labs came out with this. I'm like, that is crazy and a way better idea, because like why bother sandboxing it again, because it's already sandboxed, so you don't need to put it inside of Docker. It's already much more isolated and uniform than a Docker container ever could be, so there's no reason to put it in a container.
Yeah, that's been my argument continually, because people see Docker as being this major transformative technology, but I think it's just another stepping stone towards what will eventually be serverless. Like packaging up your code as a container is one thing, but not even having to package your code and just deliver your code to be run is the next logical step past that.
Yeah. And I think the next piece, and you're kind of seeing this trend now, there's SaaS services out there that provide databases that also provide serverless style functionality, right? So the database itself hosts the servers, right? So instead of making the server run the web code and make requests to the database, it's actually kind of the other way around. Trying to remember the company that does that. But yeah, so I definitely see a lot of Render's one that's similar. A company called Render. I think it's Render.io. They're actually they host their entire SaaS platform on top of Kubernetes, but they're basically like a super easy to use, super powered Heroku. So that, like if your app conforms to this kind of basic shape, right, where you've got, you're using a database and you're offering an application or a RESTful interface in the front end with a cached, single page app or whatever. Like if it matches this shape, it'll just like work. It's pretty cool.
Nice.
And they can deploy it all out of source. So I could see a lot of kind of, I hate to use the term converged because everyone's using that term these days, but basically there's kind of a convergence of, like custom functionality and data and web serving kind of moving to the same spot. So it's kind of interesting. So I think WASM can definitely play a part there.
Cool. Well,
Yeah.
I embrace our WASM overlords whenever they show up. So anybody else have any other questions? We're probably a little bit past our normal run time, but if anybody else has any other questions, we can take those now. Otherwise, we'll probably wrap up. Cool. Awesome. Well, thank you, Rick. That was a really cool presentation. I definitely enjoyed your slides. Next full stack is going to be August 5th, same place, same time. Look out for your normal distribution notifications of that coming in. And yeah, I hope everybody has a good 4th of July weekend with whatever your plans are there. And we'll look to see everybody at the next full stack.
Sweet.
Awesome. Thank you.
Good. Thanks, Rick. Thanks,
All right.
Justin.
Thanks all.
Awesome. Thanks, guys. Talk to you later.